Okay, now we are doing area of integration. So whenever we are finding the area, we need to keep one thing in mind that whatever the area is, that's always going to be the area under the curve. So over here it says area of the region R enclosed by the curve, which is y, which can be a function of fx, which is right over here. That's the curve shown over here. Y is equal to fx. The x-axis, this is the x-axis, so the area between the curve, the x-axis, and the lines x is equal to a and x is equal to b. So that's this and this. So we have to find the area which is bounded by the curve this, the x-axis, and these two lines is given by area is equal to integrating y, the equation y, with respect to x, that's just dx, with the upper and lower limits. This is the upper and this is the lower limit, and we get the area under the curve. This is when the equation of the curve is given in terms of x and the equation is y. So you will have something as y is equal to something, and you apply, and that y equation will be in terms of x. So you have to take the limits on the x-axis, which is over here and here. The other case would be area of a region R enclosed by the curve. Over here the function is not y like it was over here, the function is x, and that function x, the equation x, is given in the form of y, which is a function in terms of y, function f in terms of y, and y-axis and the lines y equals to a and y equals to b is given by this. So that's the equation, which is going to be x is equal to something which is going to be in terms of y, the function of y, with the limits applied along the y-axis, since the area of the curve is bounded by the curve and the y-axis, with these as the limits, the higher one as the higher limit, the lower value as the lower limit. So integrating this time x with respect to dy, since that x will be in terms of y, we take the limits of y and we get the answer. So these two are similar, but this is along the x-axis, this is along the y-axis, this with the x limits, this with the y limits. So we have a equation over here, a question that I've taken. It says calculate the area of the shaded region shown in the figure. Now that is the area which is bounded by this line, or enclosed by this line, y equals to 4, y equals to 1. This equation right over here, which has the equation of y equals to 4x squared, and this equation right over here, which is y equals to x squared. Now it doesn't say which along which axis am I supposed to find the area. It just says find this area. So I have an option, I can find the area under the graph. If I integrate this, I'll get the area under the graph with this. But if you look over here, I don't have any limits over here, and since I have the limits along the y-axis as y4 and y1, so that means I should be making x the subject over here and over here, and getting both my equations in terms of y, so I can integrate this along the y-axis. So that's what I'm going to do over here. I have my first equation as y is equal to 4x squared. If I make x the subject, I will get x squared is equal to y over 4, square under root both sides. I'll get this as x is equal to y over 2 and under root y only, because if I take under root of this and under root of this, square root of this, so I just get under root of y over 2. The second equation that I have is this, which is y is equal to x squared, which is just going to give me under root of y. I have these two limits, these two equations. If I see over here, this is the upper equation, this is the upper curve. So if I integrate this curve first, I'll get all the area, the whole area which is under the curve, with the limits applied 4 to 1. So that means I'll be getting this plus this. Then I'll integrate this curve with the same limits. I'll be getting everything under over here. So the first answer, which is going to be this plus this, minus the second answer, which is just going to give me this, is going to eventually give me the shaded region. That's the required region that I need to find, the region R. So I'm integrating the upper curve first, which is this. So I'll integrate this y dot dx for 1 area. Then I'll subtract the integrating with the limits applied of this equation, which I've got right over here, with the same limits 4 and 1. With respect to y, this is also with respect to y, since we are taking the limits of y. So if I integrate this, this is basically y to the power of half, which is square root means to the power half plus 1. Half plus 1 is just 3 over 2, so that's 3 over 2 with the limits 4 and 1, minus, if I integrate this, I get the same thing because both of these things are the same. So I'll have this as y half plus 1, which is going to give me 3 over 2, but this time I already have a 2 and the denominator, so 2 and 2 will cancel out, and I'll be just left with y to the power 3 over 2 over 3 with the limits 4 and 1. So we have y 3 over 2 over 3 over 2 means 3 and 2 over here with the limits 4 and 1. So if you divide y by 3 over 2, you get 2y over 3. You can work this out on the calculator, take anything as an example, and you get to know how this is done. Over here we get this is y 3 over 2 whole thing over 3 with the limits applied 4 and 1, and we get the answer as, if we are integrating this, we will be getting the final answer would be 2 whole 1 over 3 units square. So just plug them in. What you would need to do is, this has already been integrated, so you substitute the value of 4 first, replacing y by 4, whatever you get, then minus substituting 1, then whatever you get, 4 minus 1, minus, again, this is second equation, substituting the value of 4 first, replacing y by 4, and then y by 1, subtracting them both, and whatever you're getting eventually from this, minus whatever you were getting from this, that will give you the final answer, which is 2 whole 1 over 3.